Right, okay, so we're going to build on this, the last part that we did where I had introduced you to the idea of resistances in series and parallel. So we're just going to build on that a little bit before we come back to Ohm's law. I'm going to give you a set of questions that are work out the total resistance. Now remember, the two rules are for resistance in series, you just add them up, however many there are. And for resistances in parallel, 1 over Rp equals 1 over R1 plus 1 over R2, however many there are. But remember that you would have to, at the end, flip your answer and divide it by 1, or divide it into 1, to find Rp, because this equation gives you 1 over Rp. We don't want 1 over Rp. It's not true to say that if you can't just flip it upside down at this point, right? You can't. Rp does not equal R1 plus R2, over 1. You can't do that, because those two, that is not the same as that because of the plus signs. Okay, so don't fall into that trap. That is not true. You'd have to add those fractions before you can turn it upside down. So that's the whole point. You need to add the fractions and then turn it upside down. Okay. So basically you could say that Rp equals all underneath 1. Yeah, that's what Rp actually equals. So that's what you need to do. So you just add up the fractions and then divide it into 1, and that gives you Rp. So that's for parallel. So you've got series and parallel. Now the difficult bit could be identifying whether it's series or whether it's parallel, and that's the questions that I'm going to give you. Now, previously I've talked to you about series and parallel, and basically what I said is, if you can see a node in the circuit, but that's what defines it as being, or that's what defines these two things as being in parallel, alright? Because whatever current is coming in here splits at that node, and some goes that way, and some goes that way. And remember, it's resistance and voltage that dictate the size of the current. Higher resistances reduce the current. So basically, if this guy was bigger, 1 million ohms, and this guy was obviously then smaller, 2,700, 2K7, 2.7 thousand ohms, then that means that this guy would get less current. Higher resistance gets less current. So the current that's coming in splits at the node, and it doesn't necessarily split evenly. It depends on the sizes of the resistances. Okay, remember what current is. Current is electron flow. You won't be able to get as many electrons to flow or flow through a higher resistance as you will a lower resistance, so more current will go through the lower resistance in a parallel circuit. In a series circuit, there are no nodes. And it doesn't matter how you lay it out, right? And I'm kind of giving you a hint here that in the questions that I'm going to give you, I'm messing about with the circuit layout, but I'm telling you what the rule to identify the circuit is. You identify the circuit by identifying if it's got nodes in it. If it's got nodes in it, then the resistances are in parallel. And as much as I've messed about with the circuits in this to make them look weird, I haven't done anything to the maths of this. I'm not trying to trip you up, okay? So you are just employing this rule or this rule depending on the circuit. So you can recognise a parallel circuit by the fact that it's got a node in it, or it'll always have more than one node. It'll always have an even number of nodes in the ones I draw, alright, because they'll recombine at the other side. That's what defines them as being a parallel. So there'll always be an even number of nodes in the circuit. Right, so that's it. So that's how you identify a parallel circuit. That's how you identify a series circuit. This is how you work out total resistance if it's a series circuit. And this is how you work out total resistance if it's a parallel circuit. So let me just give you an example. If you encountered a circuit that looked like that, then you would go, the total series resistance is 6 plus 8 plus 16 is 30 ohms. You would then round it to the correct number of significant figures, but in this case that is the correct number of significant figures. Remember, you look at the data that you were given in the question. How many significant figures has this number got? It's only got 2. How many's that got? So that one's only got 1 significant figure. He's only got 1 significant figure. He's got 2 significant figures. What's the least? 1. So I must round my answer to 1 significant figure, and that is 1 significant figure. Yay, because remember, trailing zeros aren't necessarily significant unless you tell them. In this one, we would do 1 over Rp equals 1 over 1 million plus 1 over 2,700. It's important you put them into the right units. You should always be using ohms, or at the very least you should always be using the same value, and then that would be your answer. So I'll always use ohms. And then we do that calculation. So I'll go 1 divided by 1, 1, 2, 3, 1, 2, 3 equals that. And then I add that to 1 divided by 2,700 equals 93.714. So 1 over RP equals 3.714 times 10 to the minus 4. That's what it said on my calculator. That's what that E means. Yeah, you don't need to worry about what that means, right? All you would need to do is use that answer. So add it to your memory, or use the answer button on your calculator or whatever. Because what we're going to do is RP equals just what I've said up here. We flip it over. 1 divided by 3.714 times 10 to the minus 4. Now, alright, I'm writing that down and messing about with it, but on a calculator I'm not. On a calculator I've just put it into memory, and then I'm going to go 1 divided by, and then recall the memory. 2692. 269, is it 2? 2693 it would be. 2693 ohms. And then I need to round that to the correct number of significant figures. That's got 2 significant figures. That's only got 1 significant figure. I need to round this to 1 significant figure. So, is this staying a 2, or is it becoming a 3? It's becoming a 3. And the rest of them become zeros, 0, 0 ohms. And that is 1 significant figure. So that's the process if it's a parallel circuit. That's the process if it's a series circuit. Okay, you should already have done a couple of examples in the previous questions. There's another worked example, and now I'm going to ask you to do these 10 questions. And the difficulty in these 10 questions is identifying, is this in series or is this in parallel? And remember the rule that I've given you. If there's nodes, it's a parallel circuit. So, 10 questions. Make sure you try to round your answers to the correct number of significant figures. All the best.